Hello and welcome to the YouTube channel of Canara Engineering College. In today's video lecture, we'll be checking regarding the very last part of the embedded system, that is embedded system software. However, in the previous video sessions, we have checked regarding the embedded system hardware, what are the very preliminary components of the embedded system. We have checked regarding how do they work, how do they look like, what are the various subcomponents of the embedded system, and everything has been studied in detail. In this video session, we'll be checking regarding the software that is needed for the embedded system. However, we are very well aware of that for a system to function efficiently, it has to be there should be a combination of hardware and software. The software part is to be studied in this particular video session. So basically, why do we need a software? So embedded system needs a software in order to drive it. You will be having a lot of hardware components, and for those hardware components to be functioning very efficiently, you need a software to be driving it. So you can see in the figure, or you can see here, basically the embedded system is made up of four components, and those particular four components are, or they are using higher level of abstraction to get themselves separated from the hardware device. So what you can see here is, this is a hardware device. So they are using a higher level of abstraction to separate themselves from the hardware. So the basic components or the basic software components that are used in the embedded system are, one is initialization code, second one is operating system, third one is device drivers, and the fourth one is application. So when I speak it's a software, you need to understand that it's all programs or it's all codes that are written in a particular part of memory which will be making my system work efficiently once it has been turned on. So initialization, I can call it as initialization code. Operating system is also a program which is pre-written. Application is a set of codes which are written specifically for a particular application. Device drivers are also a set of codes which are written specifically with respect to the functioning of the devices or the peripherals that are connected to the embedded system. So what we'll do right now is, we'll check this particular components or the software components one by one. What are they? What are they basically doing like, or where are they residing like, or when they are coming into existence, or when they are coming into picture. The very first one, that is the initialization code. The initialization code is the very first code executed on the board or on the system and is specific to a particular group or a group of targets. So basically, when does this initialization code comes into picture as, let's say your system is turned off. Let's say your system has been turned off and you are trying to turn on. When you are trying to turn on, the system will be brought from off state to on state, or from reset state to a state where our operating system can run. So the set of codes which will be bringing your set from the reset state to the on state is called as initialization code. So what does this do? This sets up a minimum part of the board before handing over the control to the operating system. So in short, what you can say is, initialization code is a set of codes which will be helping my system to turn on from the reset state, or to turn on from the off state to the on state. That is what is initialization code. And if you're asking me, sir, where are these codes actually located? These codes are located in the ROM, that is in the read-only memory, where these codes are written by the manufacturer or by the designer, and which cannot be altered until and unless it is needed. So that is what is initialization code. Moving on to next, that is the operating system. So operating system, you people are very familiar about. This operating system basically provides the infrastructure to control the applications and manage hardware system resources. So let's say that your system has been brought from off state to on state. Once the system has been brought from on state to off state to on state, you will be having lot of applications, or you will be having lot of hardware components connected. So in order to make those hardware components to work properly, or in order to make your applications run properly, you need an environment, or you need a infrastructure. That infrastructure is basically provided by your operating system. Basically, in your embedded systems, you do not need a operating system. You can ask for a simple task scheduler. A simple task scheduler is enough for your embedded or for your embedded system instead of the operating system. That is the more than enough, because the embedded system is always like application specific. So you do not need a very accurate or very good operating system. A task scheduler will be doing the work of the operating system. So basically, when you turn on the system, it is initialization code which will set up your system. After the initialization code is done, the required infrastructure and the environment for the application and for the hardware systems to work efficiently is given by the operating system. Then comes your device driver. Device drivers you will be very familiar about. What are these device drivers? For example, let us say that you have an embedded system and you connect a let's say keyboard. Let's say you connect a keyboard. As soon as you connect a keyboard, and if you press the keys of the keyboard, none of the keys will be working here. Somewhere in the embedded system, the software or the set of codes that will be able to connect the embedded system to the keyboard, or that will be able to set up the infrastructure for the keyboard to work very efficiently in the embedded system has to be done. So those particular set of codes which will be providing a software interface to the peripherals on the hardware device is called as device drivers. You are very familiar about this, I guess. For example, if you are plugging in a new pen drive, to your laptop, it will be showing somewhere at the corner, installing device driver software. So once it is done, your pen drive is ready to use. So basically, that is what is happening here is the device drivers are getting installed, or the software with respect to that particular hardware device what you installed is getting, or it is the device is made compatible with respect to the system. That is what is device driver. Application is all about, for example, let us say you want to perform a specific task. So if you got to make your embedded system ready to perform that particular task, you should be having an application software. You should be having a set of codes that will be doing that particular task, isn't it? Those particular codes are called as application, or you can call it as application code. When you open up your mobile phone, you will be having WhatsApp. WhatsApp is nothing but it's a set of codes. So when you run those particular codes, you will be able to communicate with the person who is staying somewhere far away from here. Very similarly, in the embedded system, you will be having different applications for the different applications. But remember, these device drivers and applications can work very efficiently only if there is an operating system. Without an operating system, your device drivers, neither the application codes or applications cannot run. So as soon as you turn on the system, it is initialization code. After the initialization code is run, it is operating system. Once the operating system is run, you can connect any of the hardware devices, or you can make any of the applications run in the system. That is what it is given here. So here you can see the initialization code. This runs first, this is second, and this comes third. Application and the device driver comes next. So these are all the set of codes. It has got nothing to do with the hardware devices. Hardware devices are entirely different. When you speak of the hardware devices, you have seen what are the things that are present there. You would have seen ARM there, you would have seen controllers there, or you would have seen peripherals there, you would have seen buses there. These are all the hardwares. For this hardwares to work very efficiently in the system, you need to be having its own respective codes. That is what is your embedded system hardware. Embedded system software. However, what we are going to do right now is we are going to check how the system will be brought from the off state to the on state. Because when I say the system has been powered off, it is in the off state. Now when you turn on the power, the system should turn on, right? How does this system turn on? When will the operating system come to the RAM? What are the initialization codes looking like, or when will the initialization codes be running? All those things we need to check. So initially as you turn on the system, or when you bring the system from the, or as soon as you power on, let's say that you are turning on the power. As soon as you power on, it is the initialization code. It is the initialization code that takes the processor from the reset state to the state where the operating system can run. So remember this, it is not the operating system first which will be running, it is the initialization code which will be running first. What does this initialization code do basically? Initialization code will be configuring the memory controllers and processor caches and initializes some devices. So basically what this initialization code is going to do is, as soon as you turn on the power, it will be configuring some of the controllers, it will be configuring some of the memories, and it will also be configuring some of the simple devices. In some of the systems, maybe in some devices, operating system may be replaced by a simple scheduler, I said right, task scheduler or a debug monitor. Both will be doing the same task. So your system has been turned on, initialization code has configured the memory controllers, processor caches, and some devices has been initialized. So initialization code handles a number of administrative tasks prior to handing over the control to the operating system. So as of now, your system is not properly turned on. The initial settings, what is needed in order to turn on the system, maybe allocating of the memory, allocating of the devices, configuring the memory devices, all these things has been done. After that, after the initialization code has been taken over, it is now the work of the operating system. It is now the work of the operating system. So let us say how this operating system will be stored in the memory, or it will get stored in the RAM, so that it works properly. So once the initialization code has been run, we can categorize the phases into three phases. The first one is called as initial hardware configuration. We'll check this out in the next slide. The second one is called as diagnostic. Last one is called as booting. Booting is a process in which you know that operating system is taking over. So these are the things that has to take before you turn on the system. So first one is the initial hardware configuration, second one is diagnostic, and the last one is booting. Let's see what happens in the initial hardware configuration. So initial hardware configuration involves setting up a target platform so that it can boot a image. Boot a image means it is all about an operating system. Okay, when I say it's an image, it's an operating system. So the target platform comes in the standard configuration, but this configuration normally requires modification to satisfy the requirements of the booted image, or in order to boot the OS, it requires some modification. So basically what it is going to do is, it will have a memory. So basically what my initialization code is, this memory will be reallocated. Let's check out how this memory is getting reallocated here. Check out here. See, before the initialization code is run, that is during the off state, this is how the memory will be looking like. Once the initialization code is run, your memory will be reassigned. Check out here. This is input output registers. Fast RAM, which was next, will be coming to last. Boot ROM, which was last, will be coming second. DRAM, which was third, will be remaining the third position itself. So these are all the initial configurations what your initialization code will do before the operating system is actually taking over. That is what it has been given here. Initializing or organizing and memory is an important part of the initialization code, because many operating systems expect a known memory layout before they can start. So this is the memory what it was there during off. When it is on, my operating system will say, I need this particular memory itself if I want my operating, or I want this particular memory for the operating system to be stored. So what your initialization code is, will do is it will realign the memory. It will realign the memory and it will give the required memory to the operating system. This is what is your first initial hardware configuration. Hardware means it's a memory, right? So it is done here. Memory remapping allows the system to start the initialization code from ROM at startup. So here, your initialization code will be stored here. So after this particular codes are run, after the codes that are stored in the boot ROM are run, the memory will be realigned. The memory will be realigned. The initialization code redefines or remaps the memory map to the place of RAM at the address of 0x. I'll explain what is this 0xx. That is an important step because then the exception vector table can be in RAM and this can be reprogrammed. Initially what it does is, as soon as you turn on the system, your initialization code will run. This initialization code will realign the memory so that my operating system can come and take the control. Along with realigning of this memory, it will also see through that, some of the memory controllers are configured, some of the processor caches are configured, and also some of the devices are initialized. This is the first step. That is your first step of your turning on a system. The second step is diagnostic. Diagnostic is actually a set of code which is used to check whether the targets are working properly. Targets are working properly means your memory is working properly, your hardware devices, whatever you are connected, are working properly. All this target testing will be done as a second part of the initialization work, which is taken over by the initialization code, and this part is called as diagnostic. Diagnostics are often embedded in the initialization code. So after your system has been turned on, after the memory has been realigned, diagnostic code will be running. Diagnostic code tests the system by exercising the hardware target to check if the target is working in order. It also tracks down standard system related issues. The primary purpose of the diagnostic code is fault identification and isolation. So basically, after the system has been turned on, after the memory has been realigned, after the controllers has been configured, after the processor caches has been configured, it will check whether all the connected devices are working properly. If it is not working properly, it will report it to the user without loading the operating system. See here, if the diagnostic gives some errors, operating system will not take control of the system. It will still say the user, see, this device is not working properly. That is the work of the operating system, sorry, the initialization code. The very last process is booting. Booting is a process of, what is it going to do? It involves loading the operating system and handing over the control to that operating system. That's all it is going to do. So your initialization code is run, your diagnostic is done. If both the things are done properly, then finally booting process will take over. Booting process is nothing but loading the operating system from the RAM to the memory, so that the entire control or the infrastructure and the environment to make your hardware devices work is being set up. That is what is your last process. The boot process itself can be complicated if the system must boot from different operating system or different versions of the same operating system. Normally we do not do this. We'll make your system boot with a single operating system. Booting an image is a final phase, but first you must load the image. So what happens is, you should load the operating system to the RAM. After it is loaded, then the codes will be run. That is what it is saying. Booting the image is a final phase, but first you must load the image. Loading an image involves anything from copying an entire program including code and data into the RAM, or just copying a data area containing volatile variables into RAM. So basically this will be in the hard disk. From there it has to be copied to the RAM. So after your initialization code is run over, the data that is stored in the hard disk, that is your operating system, will be loaded from the hard disk to the RAM. Once the operating system has been loaded into the RAM, the code corresponding to that will be run, which means the control has been taken over by the operating system. Once booted, the system hands over the control by modifying the program counter to point into the start of the image. That is, once the operating system has been loaded into the RAM, your program counter will be pointing to the very first instruction so that this instructions will run. This is what is your initialization code actually doing. So this actually is a combination of the initialization code as well as the operating system. So that is actually being done by your initialization code and the operating system. Moving on further, if you want to speak about the operating system. So operating system, as I said you, it provides the necessary infrastructure and the hardware for the applications and the hardware devices to work efficiently in the embedded system. The initialization process prepares the hardware for an operating system to take control. This is done. This is all about initialization code, what initialization code does. An operating system recognizes the system resources, the peripherals, memory and the processing. Here it is going to provide you the necessary environment so that all the connected device, memories and the hardware, hardware devices will be working in tandem. ARM processor supports over 50 operating systems. This is general. How many operating systems can be made to be working now? ARM processor. There are more than 50 operating systems which your ARM can support. But basically, your operating systems are categorized into two categories. One is RTOS, real-time operating system. The other one is platform operating system. If you're asking me what is real-time operating system and platform operating system, basically, in case of your real-time operating system, provides guaranteed response time to events. Different operating systems have different amounts of control over the response time. A hard real-time application requires a guaranteed response to work at all. A soft real-time application requires a good response time, but the performance degrades more gracefully if the response time overruns. So when I speak it's a real-time operating system, I can say, yes, this particular task is going to get completed in this particular time. You can guarantee the response time. Whereas when you speak about or when you go with the platform operating system basically requires a memory management unit to manage large non-real-time applications and tend to have secondary storage. One of the complicated things. For example, Linux operating system. Here, initialization code is run, operating system takes over. Once the operating system takes over, if it is platform operating system, the response time cannot be guaranteed. Moreover, this platform operating system requires a memory management unit, MMU, in order to manage the memory. So what was happening in case of the previous one was, you had a memory and you had a slot and it was getting realigned, right? But in case of your platform operating system, the memory management unit should take care of the memory alignment. That is what is your platform operating system. However, whenever I speak about real-time operating system and platform operating system, they are not mutually exclusive. That is, there are operating system that uses an ARM core with memory management unit and have real-time characteristics, which means you can have a embedded system which is using real-time operating system and this can have MMU. It is not only that the platform operating system should be having the memory management unit. You can have it. That is up to your requirement. If your embedded system needs a memory management unit, you can have it. But again, what the problem here is, it will not only have the primary memory, it will also have a secondary memory. So memory management is a big task in case of your platform operating system. Moving on further, the last part of your embedded system software. There, the last part, if you can go with the block, you can check out here. Applications. So we'll check out applications. What are these applications basically? The operating system schedules applications code dedicated to handle a particular task. Let us say that you have a contact book in your mobile phone. So if you want to check the contacts of the various person, what you do is you press the contact book. You press the app contact book, which is an application. So as soon as you press the app contact book, a set of codes corresponding to that particular contact book will run and it will show you all the contacts. But who is going to do this? That is being done by the operating system. So operating system will be scheduling the application. The application implements a processing task. The operating system controls the environment. So all the required support in order to run that application will be provided by the operating system. Embedded system can have one or more applications running at a time. Very well and good. You can have it. In embedded systems, you can have multiple applications and more than one applications can be open at a time. ARM processors are found in numerous market segments including networking, automotive, mobile, consumer devices, mass storage and imaging. Which says that where you can find the applications of this particular ARM processor, or in the embedded system where ARM is used. ARM is used in almost all the embedded systems, starting from the automobiles. That is what I said. Starting from the very basics of the basic sensors that are used in the kitchen to the biggest of the biggest real-time systems that are used in the space networks. So this is regarding your embedded system software. Further things it is given, some more applications are given here. ARM processors are found in network applications. It is used in mobile devices. It is used in storage devices. So there are lot applications where you can find out ARM, or maybe I can say almost all the handheld devices, whatever I have, almost 92 to 93% of the handheld devices have got ARM processors as their core. So this is regarding your embedded system software. So embedded system software has got a very thick line from the hardwares. But for a system to work efficiently, or for the hardwares to work efficiently, there should be a software. And the softwares are of four kinds in my embedded systems. One is initialization code, second is operating system, third is device driver, and fourth is application. And you need to be knowing each one separately. Also, you should be knowing how a system will be turned on from the off state. When the system is moved from the off state to the on state, what are the things that are happening in the system? Initially, initialization code will run. After the initialization code is run, your operating system will be loaded from the hard disk to the RAM. As soon as the operating system is loaded, your diagnostics will happen. After the diagnostics will happen, it is the booting process which will take care. So all the things should go in tandem or intact if you need to explain the ARM embedded system software. Let's wind up our discussion for this. Thank you.